Hello, folks. So I'm going to demonstrate how to solve a certain kind of counting problem. This kind of problem involves finding the total number of digits. So for example, how many three-digit positive integers are odd and do not contain the digit 5? So whether it's a 2-digit, 3-digit, or 4-digit positive integer, you can solve this kind of problem by using the slot approach. So the slot approach involves considering, for example, the 3-digit number as consisting of 3 slots. The first slot is the hundredths digit, the second slot is the tens digit, and the third slot is the ones digit. And so the job of filling these 3 slots requires picking a digit for each slot. So for example, in this case, where we have a restriction that says we cannot pick a 5. But from 0 to 9, there are 10 digits total. And if you exclude 5, we're down to 9. And then in the case of the hundredths digit, we cannot pick a 0 because a 3-digit number cannot start with 0. It must start at 1, 2, 3, all the way, any of the digits 1 through 9, but not 0. So we cannot pick a 0 for the hundredths digit, and we cannot pick a 5, so we're left with 8 options. And then we cannot pick a 5 for the tens digit, but we can pick any of the remaining 9 numbers. So there are 9 options for the second slot. And then finally, for the third slot, because the number must be odd, we have to choose from 1, 3, 5, 7, or 9, but 5 is excluded. And so we're down to 4 options for the third slot. And so if you multiply 8 by 9 by 4, you get 288, which will be the total number of 3-digit numbers that do not contain 5 that are odd. Okay, so for the last digit, or the ones digit, we could not take 0, 2, 4, 6, or 8 because that would make the number even. Odd numbers must end in an odd digit. So in this case, we have only 1, 3, 7, and 9 to pick from, since 5 is not valid. So the total number of 3-digit positive integers that are odd that do not contain 5 is 288, which is answer choice C. So I have detailed the solution here. For the first slot, the 8 options are these numbers 1, 2, 3, 4. We skip 5, 6, 7, 8, or 9. And then for the second slot, it's 0 through 9, but no 5. And then the third slot, it's 1, 3, 7, 9. So 8 times 9 times 4, 288, answer choice C. So this is an application of the fundamental principle of counting, which states that if there are m ways of doing something, n ways of doing something else, and let's say p ways of doing a third thing, then you can do the 3 things in sequence in m times p ways. So filling these 3 slots is similar to doing 3 tasks. The first task is filling the hundredths digit slot. Second task, picking a number for the tens digit. Third task, picking a number for the ones digit. And if there are 8 ways of picking the first number, 9 ways of picking the second, 4 ways of picking the third, then there are a total of 8 times 9 times 4 ways, or 288 ways. So I hope this makes sense, and keep watching. I'm going to be posting more videos, so if you're interested, just stay tuned.